Now, hello everyone. In this third lecture on speed control methods, I will discuss today the armature resistance control method. As the name suggests, we have to vary the resistance in the armature circuit. So, what we have to do here is that in series with the armature, we have to connect some external resistance. Suppose we have connected a rheostat there. So this is R external and this is the armature resistance, that is resistance of armature circuit, and the back EMF is E. So by varying this external resistance you can control the speed of the DC motor. Now you recall the equation of speed that relates with the torque and voltage. So V upon Ke phi minus Ra plus R external upon Ke phi square into T. So this is the equation. So if you see here, if you increase the resistance here, the no load speed of the motor will not change, V upon Ke phi, only the slope will change. So as we increase our resistance in the armature circuit, the slope will increase. So the characteristics of the DC motor, which was the natural characteristics for no external resistance, if you increase the resistance there, the slope will increase and the characteristic will change like this. And if you have connected a torque to the motor which is equal to rated torque, the motor speed will be equal to omega mr for the rated condition, that is no external resistance is there, and it will reduce to omega m1 for rext1, and it will reduce to omega m2 for rxt2, which is greater than rxt1. So as we increase the resistance in the armature circuit, the speed of the motor will go on decreasing. So in that way you can control the speed of the DC motor. Now let us see what will be the various currents here. The torque is given by Ke phi into Ia. So phi you can write as, and phi depends on what? Phi depends on the current drawn by this field winding. So you can say that phi is proportional to, let me give some name, constant K into VR upon IF. VR upon IF is the current drawn by the field winding. So the flux depends on the current in the field winding. So if it is constant, so the flux will also be constant. So what about the torque? Current Ia here, it will be equal to torque divided by Ke phi. So suppose you are supplying a constant torque load, this means that the torque will remain constant. So the current drawn by the armature will also be constant. It is very surprising, but it is true that you are increasing the resistance, but still the current remains constant if the torque connected to the motor is a constant torque load. Motor has to produce that torque. So the torque is constant, so the current will also remain constant, whatever be the resistance in the external in this armature circuit. So how it is happening? That we are increasing the resistance, but still current remains constant. So this you can understand very easily. That what happens when you increase the resistance? So in the beginning, when you increase the resistance, the current drawn by the motor, which is given by V minus E, the back EMF, upon the resistance, that is Ra plus R external. So when you increase the resistance, then initially the speed, the back EMF depends on speed of the motor, phi is constant. So what happens is that as soon as you increase the resistance, the speed will not change instantaneously because the motor has a high mechanical time constant. So what will happen? Immediately after that the current will reduce, and as the current reduces, the torque will reduce in the beginning, and that will cause the speed of the motor to decrease. As the speed decreases, the back EMF will decrease, this will decrease, and ultimately in the steady state, current will come back to its original value. So in that way, current in steady state will remain constant if the torque required by the load is constant. So Ia is also constant. So this means that this Ia is constant, this If is constant. This means that the current drawn by the motor, the line current, which is equal to If plus Ia, this will also be a constant. This means that the power drawn from the source will remain constant. It is not changing by changing the external resistance. But what about, so this power input is constant. What about the power output? That is the mechanical power that is produced by this motor. This is E into Ia. So what is happening there? As we are increasing the external resistance, the back EMF, which is equal to V minus Ia Ra plus Rext, this is decreasing, and this is also equal to Ke omega m. So as we are increasing the resistance, actually Ea is decreasing, that is the back EMF is decreasing. This means that the power output is decreasing. Input power is constant, but the output power is decreasing. So actually what we are doing here is that we are wasting some of the input power in the external circuit resistance. So this means that efficiency of the motor will go on decreasing as we go on adding the resistance in the armature circuit. So in that way, you can say that the efficiency of the motor will become poorer as you increase the external resistance in the armature circuit. So this method is highly inefficient, especially when you have to reduce the speed to a larger extent. That is, you have to increase you have to add high resistance in the armature circuit. So that will cause efficiency of the machine to become very poor. So this method is inefficient and can be used only in those applications where the low speed operation is required only for short duration of time. Most of the time the motor has to run at the rated speed, but sometimes for short duration you have to run the motor at low speed. In that case, energy loss will not be too much. Even though the power loss will be there, the energy loss will not be too much, and we can use this method because it is very convenient and can be easily implemented. So every method has its application. So this method can be used in such applications where the speed control is required only for short duration. So these are the three methods of speed control that we discussed in this lecture and previous lectures. Now we have to go in details of the methods, and in the next lecture we shall discuss the armature voltage control in detail. There are various ways you can control the armature voltage. We had earlier discussed that it can be volume knot control, you can have a rectifier control, or you can have a chopper control. So these methods will be discussed in detail in the coming lectures. Thank you for today.